Right. So last week we already looked into chapter number 7. So chapter number 7 is about hypothesis testing for single population. Right. For those yang tak datang last week, you boleh tengok dalam I punya YouTube channel. Right. So I dah upload dua video. Part 1 and part 2. Right. So part 2 is about confidence interval, about mean, and hypothesis on proportion, single proportion. Right. So for this chapter, we're going to look for two population. It's the same concept from chapter number 7, right? But in chapter number 7, single population. In this chapter, two population. Right. So the learning outcome at the end of this lecture, you should be able to carry out hypothesis testing for different mean for two normal population. As we know, there are two conditions where the variance is known and variance unknown. But this one, we have extra condition where variance unknown but equal variance, and variance unknown, unequal variance. Right. And we're going to look into hypothesis testing for different mean between two proportion. Right. So it's the same concept as chapter number 7, but in this case, two population. Right. So comparing two population mean. So comparison between two different probability distribution means that we have two group, two population. We want to know whether this population has equal mean or different mean. That's all. Right. Or in terms of proportion, we want to know whether these two population has equal proportion or unequal proportion. Right, so the purpose of this study is to determine if there is a difference between the two probability distribution. So the null hypothesis usually mu A equal to mu B, proportion mean population A equal to mean population B. So this is going to be in your null hypothesis. It means that two mean from two population are equal. And for an alternative hypothesis, we're going to look into whether mean A unequal to mean B. Right? So the probability distribution are different. Right? So comparing two population mean, so we're going to look into normal distribution case, right? So the first condition, known population variance is known. Another condition is population variance is unknown. So if the population variance unknown means that we're going to look into two extra case, where case number 1 is we assume that the population variance equal. Another one is population variance unequal, right? Boleh? So before that, let me draw some diagram to show which formula to choose when we have certain condition. So let's say we have two population. Right, two population. So we have two, we're going to look into test about mean. Another one is test about proportion. So there is another case where we look into test about variance, but we're not going to discuss in this chapter, in this subject. So we're going to look into two conditions, test about mean and test about proportion. So as I said just now, when we want to test about mean, there are two conditions here, where population variance known. Another one is population variance unknown. Right. So when you have known population variance, so the formula that we're going to use is Z distribution. So in this case, it's the same concept, right? If you compare with the single population, we have x bar minus mu naught divided by sigma over square root of n, right? So this is for single population. If you have two population, x bar 1 minus x bar 2 minus mu 1 minus mu 2 divided by uh, divided by sigma square 1 divided by n1 plus sigma square 2 divided by n2. Of course, this one we take square root, right? Okay. So this is the formula when we have, we want to test about mean, difference of mean, and the population variance is known, right? So let's look at another one. So when we have a population variance unknown, so there will be two conditions here, right? So condition one, where n is more than or equal to 30. Another one is n is less than 30, which is a small sample size, right? So when we have a large sample size, if you still remember last lecture, so we still use Z distribution, right? So this one could be Z equal to x bar 1 minus x bar 2 minus mu 1 minus mu 2 divided by S1 square divided by N1 plus S2 square divided by N2. So this one we take a square root. Okay, this condition where we have unequal variance and the sample size is large, right? So how large the sample size we decide when n more than or equal to 30, right? So when n is less than 30, right? So there will be two conditions whether the population variance, we assume the population variance equal or population variance unequal, right? So of course, if you still remember, if less than 30 and less than 30, we will use T distribution. So in this case, let's say variance assume, so let's say we assume population variance equal, right? So we're going to use T distribution, which is T equal to x bar 1 minus x bar 2 minus mu 1 minus mu 2 divided by pool standard deviation multiply with 1 divided by n1 plus 1 divided by n2. So the pool standard deviation will be the square root of n1 minus 1 multiply with variance of sample variance number population number 1, n2 minus 1 population variance number 2 divided by n1 plus n2 minus 2. Right, so this is the formula for pool standard deviation. So this is what we call pool standard deviation. Right? Okay. So another condition we have when we assume population variance not equal, let's say population variance not equal, right? You should remember in this side, the population variance unknown, but we just assume population variance equal and population variance not equal. Of course, there will be a test to test whether the population variance equal or not. So in this case, we're going to use T distribution, x bar 1 minus x bar 2 minus mu 1 minus mu 2 divided by So since the population variance is unequal, so we're going to use S square divided by N1 plus S2 square divided by N2. And of course, we're going to take square root here. And the degree of freedom, if you are using T distribution, remember last lecture, we have degree of freedom. For one population is N minus 1. For two population, the degree of freedom for this one is, N1 plus N2 minus 2. But for variance not equal, the degree of freedom is a bit different. So we need to calculate S1 square divided by N1 plus S2 square divided by N2 divided by S1 square divided by N1. And then we square this one, divide by N1 minus 1 plus S2 square divided by N2 square divided by N2 minus 1. Right? So basically in your final exam or test number 2, there will be a formula given lah. Right? But you need to understand where and when to use the formula. Okay? So in this case where the population variance are known, N less than 30. Right? Done? So don't forget to sign in your attendance, yeah? So you just refer to this flow chart, and when we want to solve the problem, then it will be very easy if you refer to this flow chart. Right, the next one is we have test about proportion. Right, test about proportion. In proportion, we're going to use one Z test only. Z equal to proportion number 1 minus proportion number 2 divided by a square root of whole proportion multiply with Q multiply with 1 divided by N1 plus 1 over N2. So in this case, proportion number 1 will be equal to X over N1. Proportion number 2 will be X2, this is X1, divided by N2. And the grand proportion will be X1 plus X2 divided by N1 plus N2. So this is formula for proportion. And of course, Q is equal to the complement of proportion. Right, so Q hat equal to 1 minus P hat. And the last one is variance. We're not going to look at variance. So variance is S1 square over S2 square. So in this subject, we only look into tests about mean and tests about proportion. So again, tests about mean, we have two conditions where the population variance known, we use Z distribution. When the population variance unknown, we look at the sample size. If the sample size is more than 30, we use Z distribution. If the sample size less than 30, we use T distribution, but we're going to divide into two where the population variance assume equal and another one is population variance not assume equal. So for assume equal, we need to use a pool standard deviation. And if not equal, we need to calculate the degree of freedom. Okay. Any questions so far? Question? No question? Stapler tak? Okay. Right. So test about two normal mean when two variants are known. So this is the first condition that we're going to look when the population variants are known. So when the population variance is known, we're going to look at the assumption. The first assumption is let x1 until xn is a random sample for population 1 with mean equal to mu1 and variance equal to sigma square 1. And same goes to population number 2, right? So the two population represent x1 and x2 are independent, means that they are not related. Right? These two populations should be independent. Right? So do you understand the term independent means that population 1 is not related to population 2, right? And it will not influence population number 2. So the point estimator for the difference between two mean is mu1 minus mu2 equal to x bar 1 minus x bar 2. This is a point estimator. If your question asks you to find a point estimator, this is a point estimator. X bar 1 minus x bar 2. Right? So this is a formula, as I said just now, right? Z equal to x bar 1 minus x bar 2 minus mu1 minus mu2 divided by sigma 1 square divided by n1 plus sigma 2 square divided by n2, and taking a square root. And the null hypothesis and alternative hypothesis will be mu1 equal to mu2, mu1 not equal to mu2 for two-tail test. Right, this is for one-tail test, more than or less than, right? If you still remember chapter number 7, I already give you the rule how to find the p-value for z-test, right? So now this is a confidence interval for Z distribution where the population variance known, right? We use the standard error here. Standard error is equal to sigma 1 squared divided by n1, sigma 2 squared divided by n2. And the whole thing here is called margin of error. Right? The whole thing multiplied with Z and alpha divided by 2. This is called as margin of error. So margin of error. So it should be Z alpha divided by 2 sigma 1 square divided by n1 plus sigma 2 square divided by n2. And standard error is just sigma 1 square divided by n1 plus sigma 2 square divided by n2. Right? Okay. Just introduce you the formula that we're going to use. Right? So look at example number 1. Done? Belum? So far, do you have any question? No question? Bagus, cepat faham. Right. Let's look at example number 1. So a random sample of size n equal to 25 is taken from normal population. So it already tell us this is from normal population with standard deviation equal to 5.2. In this case, the population variance is already known, right? So sigma is equal to 5.2. Right, sigma 1 lah. This is population number 1. And n equal to n1 equal to 25 and x bar 1 equal to 81. Right? So a second random sample size 36. So n2 equal to 36 with mean equal to mean x bar 2 equal to 7.6. Sorry, 776. And sigma 2 is equal to 3.4. Right? So do data indicate the true mean, mu1 and mu2 are different. Carry out test at alpha 0.01. So we need to carry out the hypothesis whether to test whether the true mean mu1 and mu2 are different, right? So null hypothesis, mu1 equal to mu2. Alternative hypothesis, mu1 not equal to mu2. And alpha equal to 0.01. So since the population variance is known, right? Test statistic will be Z equal to x bar 1 minus x bar 2 minus mu1 minus mu2 divided by sigma 1 square divided by n1 plus sigma 2 square divided by n2, right? Okay. So x bar 1 is equal to 81. So 81 minus x bar 2 equal to 76. 81 minus 76. Minus mu1 minus mu2. So if you look at this one, right? Mu1 minus mu2 equal to 0. Right? If you take mu2 to the left hand side. Mu1 minus mu2 is not equal to 0. So mu1 minus mu2 should be equal to 0. Right? So divide by sigma. Sigma 1 is equal to 5.2. Just sigma square divided by n1 equal to 25 plus 33.4 square divided by 36. So this one going to be 4.22, right? So 4.22. So this is two-tail test, right? So if you look at this alternative hypothesis is unequal. So it should be two-tail test. Critical region will be, you're going to have two rejection region, right? So rejection region on the right hand side and left hand side. So this one should be 0. This is Z, negative Z alpha divided by 2. This is Z alpha divided by 2. This is rejection region. This is also rejection region. And the area in the middle will be acceptance region. Okay. So Z alpha divided by 2. So our alpha is 0.01. Right? Z alpha divided by 2 should be Z 0.005. Right? So 0.005, if you look at the statistical table, so please open your statistical table. Statistical table. So your statistical table read the data to the left hand side, right? So Z 0.05 is to the right hand side. So we need to minus by 1. So 1 minus 0.05 should be equal to how much? 0.995, right? 1 minus 0.005. 0.995. So 0.995 should be somewhere between these two value, which is 2.57 and 2.58, right? It should be, if you take the middle value, should be 2.575. Okay. So our decision here is since Z calculated, so what is the Z calculated? This is Z calculated 4.22 more than Z alpha divided by 2, then null hypothesis is rejected. Right? So since we reject null hypothesis, conclusion will be, so the data shows okay. So the conclusion will be alternative hypothesis lah. So we accept alternative hypothesis. Okay. Right. In hypothesis testing, you just need to understand the condition from the statement, whether population variance known or population variance unknown, right, and the claim. So then we can perform the hypothesis test, right? So now, this is about the hypothesis testing. Let's say I want to find 95% confidence interval. So let's say I want to find 99% confidence interval of two mean of different between two mean, right? So the confidence interval, just now we already look at the formula, right? It should be probability of x bar 1 minus x bar 2, right? Minus z alpha divided by 2 square root of sigma square 1 divided by n1 plus sigma square 2 divided by n2. This is mu1 minus mu2. So the same value will be on the right hand side, x bar 1 minus x bar 2 plus z alpha divided by 2. This is sigma 1 square over n1 plus sigma 2 squared divided by n2. So this one should be equal to 100% 1 minus alpha. So this is the formula for confidence interval, right? We already looked at slide number, previous slide, right? So from the statement, we know that, x bar 1 is equal to how much? 81, right? 81, x bar 2 equal to 76, and then sigma 1 equal to 5.2, sigma 2 is 3.4, and 1 equal to 25, and 2 equal to 36. So this is the value from the statement, right? Example number 1. So we just plug in the value into the formula. So you just plug in the value into the formula. X bar 1 minus x bar 2 should be 81 minus 76 minus z alpha 0.01 divided by 2, 0.005, multiply with 5.2 square divided by 25 plus 3.4 square divided by 36. So this is the lower limit, the lower confidence limit, right? And then mu1 minus mu2, upper confidence limit. It's the same thing, but we plus, right? Plus z 0.005 square root of 5.2 square over 25 plus 3.4 square over 36. So this one should be equal to 99%. Okay. So from previous, we know that Z alpha, Z 0.05 is equal to 2.575, right? So you kira this one, calculate this value. So you will get probability of 1.944 mu1 minus mu2. And then this one is 8.055 equal to 99%. Okay. So how to interpret this confidence interval? Right. So of course you need to calculate this one. Replace Z alpha, Z 0.005 is 2.575. Okay. Any questions so far? Question? Soalan? Any questions so far? No. Done? Ini formula ni sikit saja. Next topic lagi banyak formula. Done? Can we move to the next question? So example number 2, I think we do until example number 2. I leave it example 3, 4, 5, 6, 7, 8 until 10 ni you buat sendiri, okay? So example number 2, burning rates of two different solid fuel propellant used in rocket system being studied. So let me, right? It is known that both propellant have approximately same standard deviation. So it has the same standard deviation of burning rate. So that is 3 centimeter per second. Two random samples with same sample size, 20, are tests. And the sample mean burning rate are 18 centimeter per second and 24. So in this case, we have N1 equal to 20 and 2 also equal to 20. And then we have X bar 1 equal to 18, X bar 2 equal to 24. And we have standard deviation, number 1 equal to 3, standard deviation number 2 equal to 3. Right? So the question asks, test the hypothesis that both propellant have same mean burning rate. So using p-value approach. Okay. So the null hypothesis will be mu1 minus equal to mu2, right? Alternative hypothesis mu1 not equal to mu2. So this is also equal to mu1 minus mu2 equal to 0. Mu1 minus mu2 is not equal to 0. And we want to test at alpha equal to, so if the question does not state the value of alpha, so we assume alpha equal to 0.05. Okay. And we calculate the test statistic. So since this is a population variance known, so we're going to use Z distribution, x bar 1 minus x bar 2 minus mu1 minus mu2 divided by square root of sigma 1 square over n1 plus sigma 2 square over n2. And we take a square root for this one. Right. So you plug in the value, x bar 1 is equal to 18 minus 24 minus 0. Right. How do we get 0 here? Because the null hypothesis mu1 minus mu2 equal to 0. Right. Divide by sigma 1 is equal to 9. Sigma 1 square, right? Sigma 1 is equal to 3, square equal to 9 divided by 20 plus 9 over 20. Taking a square root. So this one should be equal to negative 6.32. Okay. And then step number 3, we find critical region. So in this case, the alternative hypothesis is unequal, right? Not equal means different. This is a two-tailed test. So this one should be, we're going to have two rejection region. So this is rejection region number 1, rejection region number 2. This is 0. Right? We are using Z distribution. So negative Z alpha divided by 2. This is Z alpha divided by 2. You know that this is a rejection region, right? Rejection region. This is acceptance region. And this is rejection region. Right? So Z alpha divided by 2 is equal to Z 0.05 over 2. So this is Z 0.025. So Z 0.025 is equal to 1.96. So how to know this one, this value? 1 minus 0.025 is equal to 0.975. So we look at the statistical table. 975 is 1.96. Right? Okay. Boleh? 0.975 is 1.96. So since the population, the critical value is 1.96, so this one should be negative 1.96 and this is 1.96. So our decision, since Z calculated is less than negative Z alpha divided by 2, null hypothesis is rejected. Basically, to understand this, if the Z value, Z calculated, this value, right? This is the Z calculated, lies inside the rejection region, then we reject null hypothesis. Right? So easy to understand. Right? If you cannot understand the decision rule. Okay. So since we reject null hypothesis, the conclusion will be we conclude based on alternative hypothesis lah. So both propellant do not have the same. So this is by critical value approach, right? So, but the question asks us to use p-value approach. So to use p-value approach, let me put on the right hand side. P-value approach. The conclusion should be the same, p-value and critical value, right? So p-value approach, p-value for two-tailed test is 2, 1 minus probability of z less than z calculated, right? So it should be 2 1 minus probability of z less than negative 6.32. Okay. So negative z, z negative 1.6.32. If you look at this the table, we only have until 5, right? We only have until negative 5. So this one is actually near to 0 lah. Oh, sorry. Sekejap. This is supposed to be absolute, right? So this one absolute. So it should be less than 6.332. So it should be down here. So z less than 5 is near to 1, right? 0.99997. So 6 we assume equal to 1 lah. So this one should be 2, 1 minus 1 should be equal to 0. So it means it's not actually 0, but it's approaching to 0. Means a very small number, right? So since p-value less than alpha, our alpha is 0.05, null hypothesis is rejected. Right? It should conclude the same as p-value and critical value approach. Okay? Boleh? Any questions so far? Yes. So based on the statement lah, it said it came from a normal population. So it means that the standard deviation is known, right? If the population variance are known, means that the standard deviation is calculated from the sample. Okay, so the next part, which is B, so we want to, this is mu, mu1 and mu2, right? So construct 95% two-sided confidence interval on different means, mu1 minus mu2. What is the practical meaning of this interval, right? So let me put down here. So B, probability of x bar 1 minus x bar 2 minus z alpha divided by 2 sigma 1 square over n1 plus sigma 2 square over n2. So this is mu1 minus mu2, x bar 1 minus x bar 2 plus z alpha divided by 2 square root of sigma 1 square sigma 2 square. Right, this is 1 minus alpha. So we just plug in the value into the formula. So P 18 minus 24, right? 18 minus 24 minus Z alpha divided by 2. This is a 95% confidence interval. So be 1.96 multiply with 9 over 20 plus 9 over 20 mu1 minus mu2 18 minus 24 plus 1.96 9 over 20 plus 9 over 20. So this is going to be 95%. So can you calculate now what is the value? Right. So this one should be probability of negative 7.589 mu1 minus mu2. This is negative 4.141, 95%. So what is the value of mu1 minus mu2? Don't know? Takkan tak tahu. Mu1 minus mu2 is equal to 0, right? Since the value of mu1 minus mu2 is not in the interval, then null hypothesis is rejected, right? So if mu1 minus mu2, the value of mu1 minus mu2 in the interval means that there are no significant difference lah, right? So since in this confidence interval, the value of mu1 minus mu2 equal to 0 is not in the interval, so then we can say that these two population is different. Okay, boleh? Any questions so far? Soalan? No question? Right, done? Sudah? Yes. Oh, nak tulis? So remember our quiz this Thursday, Right. Thursday, 8:30 to 9. You all okay kan? Okay or not okay? You're right. Okay, dah belakang sudah? Belum? Alright. For example number 3, 4, 5, 6, 7, 8, 9, 10. Right? It's the same concept. So I think you can practice by yourself. So if you have any problem for answering example 3 until 10, so you can contact me. Okay? Done? So example number 3, 4, 5. So 3 ni banyak, we have a lot of data you need to calculate by yourself, right? And 5, 6, 7, 8, 9, 10, I think you do by yourself. Now we're going to look at tests about 2 mean when 2 variants are unknown. You want to proceed or take 5-minute rest? Okay, good.
So,
Yeah.
Thursday night, I got another class. They say Japanese communication.
Oh, you just message me tadi.
Yes.
Oh, nanti I tanya lebih baik macam mana, nanti I get back to you.
Okay, boleh. Thanks.
Yeah. Sebab kalau tengok dekat null hypothesis, mana null hypothesis tadi? Null hypothesis ni equal to 0 kan? So kalau value 0 ni dalam interval, right, it means that dia dalam ni lah, maksudnya dia not apa, tak ada different lah. Kalau dia tak sama dengan kosong, right, nampak tak? It's not equal to 0 kan? The value of covariant interval tu tak contain 0. So maksudnya dia ada different. Nah, macam ni. Tengok ni. Mana tadi yang covariant interval ni? This one, right? Kalau dalam interval ni ada 0, so this one kalau tengok tak ada 0 kan? 0 tak inclusive kan? So -7 to -4. So means that we accept alternative hypothesis. We say that these two population mean different. Right? Kalau dalam ni ada 0, right? So means that they are no different lah. Sebab hypothesis, null hypothesis sama dengan kosong. So, faham tak kenapa dapat kosong tadi tu kan? Sebab mu1 sama dengan mu2. So kita bawa mu2 ke situ dapat kosong lah. Alright. Alright, can we continue? Boleh sambung? Belakang okay? Boleh sambung? Can we continue? Alright, let's continue on the next part, which is test about two means. So remember, we still under testing about mean when two population variants are unknown. So remember, just now we already discussed on the diagram, when we have a population variance known, so we use Z distribution. When the population variance unknown, we're going to look at the sample size. If the sample size more than 30, more than or equal to 30, use Z distribution. If the sample size less than 30, we're going to look at another two conditions, whether the population variance equal or not equal. If the population variance equal, use T distribution with full standard deviation. If the population variance not equal, use normal T distribution, but calculate degree of freedom, right? So now, let's look at the first case where the population variance assume equal, right? So this is the formula. The hypotheses are same, right? We want to test whether the mean of first population and second population equal or not equal. Right? Either another one is if mean population 1 more than population 2 or mean population 1 less than population 2. So if this is example of one tail test. So this is an example of two-tail test, right? So we're going to use t distribution, right? Where x bar 1 minus x bar 2 minus mu 1 minus mu 2 multiply with, divide by pool standard deviation multiply with 1 over n1 plus 1 over n2, right? And the pool standard deviation is the square root of n1 minus 1 multiply with sample variance 1 plus n2 minus 1 multiply sample variance 2 divided by n1 plus n2 divided by 2. And n1 plus n2 minus 2 is the degree of freedom for t-test, right? Okay, so this is a case number 1 where the population variance assume equal, right? So it's the same thing. Now the confidence interval based on the t distribution tadi, the t statistic, right? So this value is called standard error, right? The whole value, inclusive critical value, we call as margin of error. It's the same thing on the left hand side also have. Okay. Now let's look at example number 11. So Professor Adam taught the same large lecture course for 2 terms. Except for negligible difference, the course were same. However, one met at 8 a.m. and another met at 11 a.m. The 2 courses were given final exam of the same degree of difficulty, right, and covering the same material. Both exam worth 100 points. So a random sample, now this is the point, right? The random sample of 16 students from 8 a.m. class had an average score 73.2 with standard deviation 8.1, right? So if you notice, the standard deviation is calculated from 16 students, right? Another group, right? Another group, a random sample of 16 students from 11 a.m. class had an average score 78.1 with standard deviation 10. So we assume that population variance are same. So this is the condition. We assume the population variance are same and the data from normal distribution. So let's take down the point. So N1 equal to 16, N2 also equal to 16. X bar 1 equal to 73.2, X bar 2 equal to 78.1. And the standard deviation S1 equal to 8.1, S2 equal to 10, right? So we assume the population variance equal, right? So question number 1, do these data indicate that the mean score for 11 a.m. class is higher than mean score for 8 a.m. class? So this is mu1, this is mu2, right? Okay. So now, to solve the problem, we need to perform hypothesis testing. So null hypothesis, mu1 equal to mu2. The alternative hypothesis, mu1 less than mu2. So the claim is whether the mean score for 11 a.m. class is higher than mean score 8 a.m. class, right? So alpha equal to 0.05. And then our test statistic So T equal to x bar 1 minus x bar 2 minus mu1 minus mu2 divided by Poole standard deviation 1 over n1 plus 1 over n2. Right. So the value of Poole standard deviation SP is equal to the square root of n1 minus 1 s1 square plus n2 minus 1 s2 square divided by the degree of freedom n1 plus n2 minus 2. So this one should be equal to n1 is equal to how much? It's 16, right? So 16 minus 1 equal to 15 s sigma square 1 8.1 square plus 15 10 square divided by 16 plus 16 minus 2. So what is the value here? Can you calculate? Should be 9.10. So then you plug in the value into the formula. X bar 1 is equal to 73.2 minus 78.1 minus 0. How do we get 0? So mu1 minus mu2 equal to 0. Mu1 minus mu2 less than 0. Right. So divide by 9.1 multiply with 1 over 16 plus 1 over 16. Taking a square root. So this one should be negative 1.52. Can you recalculate? I tak sure my jawapan betul ke tak. Right. Can you confirm this answer? Sama. All right, good. Right, critical region. So critical region, in this case, we have mu1 less than mu2. So this is one tail test, right? So where is the rejection region? On the left or right? Left, right? Should be on the left. So this is 0, T. So the value here is negative T alpha with degree of freedom. And this is rejection region lah. Rejection region. This is acceptance region. Okay. So T alpha. So since we only have one, this is a one tail test. We don't need to divide by 2. Right? With degree of freedom. So what is the degree of freedom? Degree of freedom is equal to n1 plus n2 minus 2, which is 16 plus 16 minus 2 equal to how much? 30, right? Okay, so this is T 0.0580. Should be negative 1.697. So this is the actual value, but I don't think it will be in your statistical table. But it's okay. In test, normally we will give you whatever value in statistical table. Right. So next, the decision since T calculated. So T calculated is negative 1.52 is more than T negative T alpha with degree of freedom. Null hypothesis is accepted. Right. right? So we accept null hypothesis. It means that we cannot say that mean score uh, class at 11 a.m. is better than 8 a.m. Okay. So next question is, what is the p-value for this test? What is your conclusion? The conclusion should be the same, right? As a critical region, right? But we need to calculate the p-value. So p-value for t-test, as I said on last class, the p-value on for t-test, we're not going to have exact value. We're going to estimate the value, right? So from here, we know that the degree of freedom is equal to 30. T calculated is equal to how much? 1 point. This is a sigma. Sorry, absolute 1.52. And we look at the statistical table. So this is a less than issue. Look at the statistical table. Look at T distribution with degree of freedom equal to 30. Degree of freedom equal to 30. 1.9697. This is the value of critical region, kan? But 1.552, right? This is T calculated. If you can see, 1.52 is between these two value, right? Betul? 1.52 is between these two value. So the P value will lies between 0.1 and 0.05. Right? So the P value should be between 0. How much? 0.1 and 0.05. Right? Means that the P value is larger than 0.05. Our alpha is 0.05. So since P value is more than alpha 0.05, null hypothesis is accepted. Right? So we fail to reject null hypothesis. Okay. The conclusion should be the same as critical value approach. Okay. The last question, done, right? Any question for p value? That's all. So last question, construct 95% two-sided confidence interval for different in mean score, interpret the interval. Right. So for C, so we want to calculate the 95% confidence interval on the different in mean. So this one is 9.1, right? Betul? Full standard deviation is 9.1, right? Okay. So this is the value that we pick up from the question. So the confidence interval is x bar 1 minus x bar 2 minus T alpha divided by 2 with degree of freedom, and SP multiply with the square root of 1 over n1 plus 1 over n2, mu1 minus mu2. This is x bar 1 minus x bar 2 plus T alpha divided by 2 with degree of freedom, SP multiply with 1 over n1 plus 1 over n2. So this one should be 1 minus alpha. Right? So we plug in the value into the formula. This is 73.2 minus 78.1. So in this case, just now we look at the one-tail test, right? So in this case, we have T alpha divided by 2 with degree of freedom, right? It should be equal to T 0.025 with degree of freedom equal to 30. So the value of degree of freedom equal to 30, alpha 0.05 should be 0.05, 0.025 should be 2.042, right? This is alpha 0.025, degree of freedom equal to 30. So 2.042, right? So minus 2.042 multiply with 9 over 9.1 multiply with 1 over 16 plus 1 over 16. So on the right hand side, sama lah, same. 73.2 minus 78.1 plus 2.042, 9.1, 1 over 16 plus 1 over 16 equal to 95%. So you need to calculate this one. The lower confidence limit and upper confidence limit. So the lower confidence limit is negative 11.47 mu1 minus mu2. The upper confidence limit is 1.67, which is equal to 95%. This is actually mu1 minus mu2 lah. Mu1 minus mu2 equal to 0. So since the value of 0 is inclusive in the interval, so then we accept null hypothesis lah. So the result here should be same as hypothesis testing. Okay, done. Any question? You want to see another example? Or the one? Look at another example. This is a different hypothesis test from previous, but it's the same concept, right? Oops. So diameter of steel rod manufacture on two different instruction machine is being investigated. Two random sample N1 equal to 15 and 2 equal to 70 are selected respectively. Assume data are drawn normal distribution with equal variance. Oh, ni soalan ni ada missing. Right. I tulis tak habis. Sekejap ya. I tulis penuh ni kat sini. Right. This is X bar 1 equal to 8.37. X bar 2 equal to 8.68. S1 square equal to 0.35. S2 square equal to 0.40. Right? Okay, so we know that N1 equal to 15 and 2 equal to 17. So the question is there any evidence to support the claim that two machines produce rod with different mean diameters? So it asks us to use p-value approach, right? Null hypothesis mu1 equal to mu2. Alternative hypothesis mu1 is not equal to mu2. Alpha equal to 0.05. Right? So then we need to calculate the test statistic. So in this case, how do you choose test statistics? So we know that the population variance unknown, right? The population variance unknown, the sample size is very small, n less than 30, and we assume equal variance. Right? So we use T distribution with pool standard deviation. Right? So T X bar 1 is equal to 8.73 minus X bar 2, 8.68 minus 0 divided by pool standard deviation multiply with 1 over 15 plus 1 over 17. Right? So this is a basic concept or the formula. Right, so then we need to calculate the pool standard deviation to be equal to N1 minus 1, 15 minus 1 equal to 14, multiply with the standard deviation square. So in this case, we already have variance equal to 0.35 plus N2 minus 1 equal to 16, multiply with variance, sample variance number 2, 0.40. Divide by N1 plus N2 minus 2. Right? Okay. So this one should be equal to 0.6140. Later you recalculate balik whether my calculation is correct or not. So this one should be 0.6140. Okay. So this is two-tailed test. If you are using critical value approach, let's look at both approach lah. Critical value approach. So this is two-tailed test. we're going to have two rejection region. So negative T alpha divided by 2 with degree of freedom. This is T alpha divided by 2 with degree of freedom. T alpha divided by 2 degree of freedom is equal to T 0.025, 0.05 divided by 2, 0.025. And degree of freedom, so what is our degree of freedom? 15 plus 17 minus 2, right? So it should be equal to 30, right? So this one should be equal to 30 and it's the same as before, 2.042. So then our decision here is, since the p-value, the t calculated, since t calculated is less than T alpha divided by 2 with degree of freedom, null hypothesis is accepted, right? So how do you know? So the T value, this is 2.042, this is negative 2.042. So 0. This is 0, 0.23 somewhere here, right? 0.230 lies inside the accepted region. So we accept null hypothesis. Okay. So our conclusion is, so what is our conclusion? Two machine do not produce okay. So if you are using p-value approach, since the question asks you to use p-value approach, so p-value approach, right? So p-value for two-tailed test, it should be equal to 2 multiplied with probability of t more than t calculated, right? So it should be 2 probability of t, this is t degree of freedom, right? T30 more than t calculated is 0.230, right? So we look at the statistical table, degree of freedom equal to 30, 0.230 is somewhere before less than 0.26, right? Okay? 0.230 is less than 0.26, right? So the alpha would be 0.4, right? So the p-value is 0.4. So 2 multiplied with 0.40 equal to 0.80. So since p-value is more than alpha, our alpha is 0.05. Null hypothesis is accepted. Okay. So how do we get this one? So I tulis lah, senang you nanti ingat ya. So based on T table, right? At degree of freedom equal to 30, the value of 0.230 is less than 0.256. So which at alpha 0.40. So that's why alpha equal to the value of probability is 0.40. Okay. Any question? Soalan? Yes. Mana Min? Ah, mana Min mana? Min dekat atas. I tak faham. What is it? Apa? Oh, diameter. Right. B, we want to find 95% confident interval. 95% confident interval of mean. So it's the same concept lah as previous, right? Let me copy the this one, this formula. Copy. Oops. Okay, so you just plug in a value into the formula. So probability of this is 8.73 minus 8.68 minus 2.042, 0.614, 1 over 15 plus 1 over 17. So since zero inclusive in the interval, right? So null hypothesis is accepted. So means that there are no different on mu1 and mu2. Okay. So example number 13. This one done, right? Example number 13, I just want you to calculate the confidence interval. Right. So it's the same concept from previous. Example number 14, I think you can do it by yourself. Example number 15, this is more than or equal to, right? So we want to find, the claim is, can you conclude that the mean time spent watching television in New York State is greater than in California? So mu1 more than mu2, right? So example number 15, 16, 17, 18, until 20. I think you can do by yourself. Right. Or you want me to show? Don't want. If you understand the example 11 and 12, I think you can do the rest. Right? Okay. Okay. Ada soalan tak? Any question? No question? Yes. Example 12. Okay. So we will continue on tomorrow lah. Sebab masa pun tak banyak lah. 15 minit tak sempat. Yeah. So tomorrow we will look into population variance unknown, but we assume unequal. So this is very hard to calculate. And then we will look into when the sample size is very large, when n is more than 30. And the last part is two proportion. That's all. Then we finish chapter number 8. Right? And prepare for test number 2. Okay? Any question? Any last question? There no question. All right. Then that's all. Thank you very much. Assalamualaikum.